Hello everyone, welcome to my YouTube channel. I'm Chamidu Kasunkarnaratna. In this YouTube channel, we are discussing topics related to information technology and computer science. In today's tutorial, we are going to discuss about Internet of Things, or IoT for short. So we will start by understanding what is IoT, and then we will dive into creating our very own IoT project using Arduino IoT Cloud. So I welcome you all again, and let's get started. Let's understand what exactly is IoT. IoT stands for the Internet of Things. As you can see, the term is derived from two words, Internet and Things. The Internet is a vast network that connects computers and devices all over the world. So, which has enabled people to share information and communicate from anywhere within the world. For an example, think about social media, email. However, in this interconnected world, humans have always been the central part of communication. Like whether it's sharing a post on social media, sending an email, or searching for some information in the web, human interaction has been the key. So this is why this is often refers to as the internet of people, where people are the main component of this network. However, as technology evolved, people began to ask, can devices communicate and share information without human interaction? So this is the question that gave birth to the Internet of Things. So unlike Internet of People, where human drive the interaction, IoT focuses on connecting devices. So connecting devices, sensors, and everyday objects to the internet. So these devices collect data, exchange information, and perform actions autonomously without a human interaction. So IoT focuses on connecting devices. So just like human were the main component of the internet of people, devices and objects become the main component of internet of things. So for an example, think about a wearable fitness tracker which will be monitoring your heart rate, count your steps, and measure how long you have been active during the day, and provide personalized health insights to your smartphone. Or think about a smart light system which you can control with your phone. So even when you are not at home, you can turn on or turn off the light system. Or think about a security camera, smart security camera, which can send alerts to your phone. So it's keeping your home safe even when you are away. So we can define IoT as a network of interconnected physical devices that communicate with each other over the internet. These devices use sensors, software, and cloud technologies to collect, process, and exchange data, enabling them to perform tasks autonomously and conveniently. If we look at the history of IoT, in the 1970s, the development of wireless networks laid the groundwork for devices to communicate without physical connections. By the 1980s, commercial cellular networks emerged. They opened up the possibility for wireless data transmission. And in late 1980s, they have created a Coca-Cola vending machine at Carnegie Mellon University that can report drink availability to students is considered as one of the first uh, IoT examples. In 1999, British technologist Kevin Ashton introduced the term Internet of Things. He was a scientist working with RFID technology to connect physical devices through microchips and wireless signals. Ashton visioned about a future where physical devices could connect to the internet through microchips and using wireless signals, they communicate and share data. In the 2000s, with the widespread adoption of broadband internet and wireless networks, uh, IoT growth accelerated and businesses started using IoT technologies to optimize their production, manufacturing, logistics, likewise. And by the 2010, Amazon introduced Amazon Echo, which is a smart home device, and IoT continues to grow. Today, with the advancements of 5G, cloud computing, and AI, IoT connects billions of devices and transforming various industries like transportation, agriculture, and healthcare. So, it is revolutionizing how we interacting with the physical world. Let's look how IoT is being used in different industries today. Healthcare. In healthcare, IoT devices like wearable health trackers and smart medical equipments are using to monitor patients in real time. For an example, think about a diabetic patient. So rather than examining him time to time by a doctor, he is given a fitness band that can track his heart rate, blood pressure, and physical activity throughout the day. Let's say whenever his glucose levels are lower, he needs to give treatments. So rather than waiting until a doctor come and examine him and prescribe medicine, based on the fitness tracker's data, using a smart medical equipment, we can give him the necessary treatments. So the time delay that takes uh, a doctor to examine him and give the treatment is we can reduce that, so we can ensure that patient gets the necessary treatment at the right time, right? So also hospitals are using IoT to monitor equipments, manage patient beds, and ensure better patient care using IoT. Agriculture. In agriculture, IoT devices such as smart sensors and drones are used for farming. These devices monitor soil moisture, temperature, and weather conditions to optimize water usage and improve crop yield. For an example, farmers can use IoT based irrigation systems to water crops only when necessary, so which will save resources and improve efficiency. Transportation. So IoT is transforming transportation in a very rapid rate. So uh, because of IoT, today we have self-driving vehicles. So these vehicles use IoT based sensors and GPS systems to gather data, and they communicate with internet to get data about the roads, like which road has the least traffic, and they analyze them and navigate safely and faster. So organizations use IoT to optimize their supply chain. It's like uh, so using IoT, they are able to reduce delays and ensure efficient delivery. Also, we need to understand that IoT is not a standalone technology. So it works hand in hand with technologies like AI, cloud, blockchain, etc. For an example, IoT devices collect large amount of data from sensors and other connected devices. But this raw data is often meaningless. So we use AI to analyze them and to come up with intelligent decisions. So using AI, we can um improve the efficiency of the system. Like then we can use cloud to store that large amount of data. Right? So as an example, think about a smart thermometer. Like from the thermometer, we collect temperature data. Then we use AI to analyze that data and uh, the we can optimize energy usage using AI. So we can see this combination uh, enhance the device's functionality, and it allows the IoT systems to make smarter decisions and the system to be more efficient over the time. All right. So now we understood what is IoT, why it came to existence, and the history of IoT and how IoT works and how it is transforming industries worldwide. So with that basics covered, let's move to our project. So for this project, we will use Arduino IoT Cloud. And in this project, we are going to build a smart light system that allows us to turn a bulb on or off remotely using Arduino IoT Cloud. So imagine you have a light bulb in your house. Normally, you walk to the switch and turn it or turn off. But now we try to control it with using Arduino IoT Cloud. Before diving into the project, first let's understand how IoT devices work. So, IoT devices communicate using both wired and wireless networks. As an example, Ethernet for wired connections, Wi-Fi, Bluetooth, RFID for wireless communications. So typically IoT devices connect to IoT gateway or a edge device. So using this IoT gateway, they send data to cloud platforms. The cloud environment serves as the central hub where the data is stored, processed, and analyzed. And several communication protocols are used for communications, uh, such as MQTT and HTTP. IoT communication requires lightweight, reliable protocols that can efficiently transfer data. So, MQTT or Message Queuing Telemetry Transport Protocol is a lightweight, published subscribe protocol designed for devices with limited bandwidth and power. So, there is a central server called broker, and client devices send or publish data to the central server. So based on the topic they publish, the central server distribute the data to other client devices called subscribers. So there are brokers called Mosquito likewise, and which will we will be going deeper when we creating our project. HTTP, Hypertext Transfer Protocol, is commonly used for web-based IoT applications, and it is suitable for devices with wide bandwidth but less efficient for power-limited systems. So, all right. So, with that understanding, let's dive into our project. Uh, at the end of this project, you will get a solid understanding of how IoT devices connect and communicate. So the first step in creating our project is setting up the circuit. So we have two options. We can either purchase an IoT compatible microcontroller such as ESP32, or we can use a simulator. So for everyone's convenience, in this tutorial, I'm going to use a simulator. So for this project, we will use a simulator called Wokwi. So Wokwi is a free online simulation platform that allows us to design, simulate, and uh, test microcontroller-based projects. To create the project, first go to wokwi.com. Here you can sign up with your email. So here you can see they have given us different controllers and some sample projects. So here we need to select a controller which is an IoT compatible controller. IoT compatible means it need to have the ability to access internet. So after that, from the starter templates, select ESP32. So then you will get two panels. Uh, right panel is where we design our uh, circuit board, and left panel is where we write our code uh, to the microcontroller. By pressing on this plus icon, you can uh, select items like LED, resistor, likewise. So first, we will add the LED to the board. And then we will add a resistor. We know LED has two pins, anode and cathode. So the anode need to be connected to a ESP pin of the ESP board, and cathode need to be connect uh, to the ground pin of the ESP board. So we will first connect the anode to a ESP pin. Uh, let's connect it to ESP12 pin. Then uh, connect the cathode to the resistor, and then connect the resistor to the ground pin of the ESP32 board. So now let's write our code. I need this LED to blink uh, in a blink uh, with a 1 second delay. So first I need to define to which pin I have connected my LED. So I will give a name as LED pin, and I connect it to the 12th pin. So in the setup function is where uh, we describe about the circuit setup. So uh, I'm saying pin mode LED pin is a output pin. LED pin is a output device. Then this loop function will be running continuously when we run the project. First I say digital write, make the LED pins voltage high. Then get a delay of 1 second. Then make the LED pins voltage low. Low. Then get a delay. So after the delay, the loop will be go to the ninth line. That means it will make the voltage high. So this will be continuously running as a loop. So let's run this project. So you can see it's compiling, but here uh, you can see it's takes some time, like some like 2-3 seconds it's taking to compile. Okay, it got compiled, and you can see as we expected our LED is blinking. So so uh, after uh, with the 1 second delay. Alright, now let's move to our project. So first create a new folder in your desktop and rename it as Smart Light System. Then open the folder with Visual Studio Code. So to create IoT applications with Visual Studio, we need to install two extensions. So go to extensions tab and search for PlatformIO. Then select PlatformIO IDE and install it. PlatformIO is a development environment that allows us to write, compile, and upload code for microcontrollers like ESP32. Then search Wokwi and install Wokwi simulator. Right, now let's go to wokwi.com and let's create our circuit setup. So I'll select ESP32, like previously did. uh, I'm selecting a LED and a resistor. Connect the anode of the LED to a ESP pin. Let's connect to ESP2. Then add a resistor. Then connect the cathode of the LED to the resistor and connect the resistor to the ground pin of the ESP board. So right, then let's color this as black, so for the clarity. Okay, so this is our setup. So what I want is, as I said, ESP32 is a IoT compatible microcontroller. That means uh, it has the it can connect to Wi-Fi networks. So and it can connect to internet. So I want my ESP32 controller to connect to Wi-Fi. Then if successfully connected, I want this LED to blink. So we'll go to PlatformIO and create a new project, right? So select create new project, right? Let's name our project as Smart Light System. Then select the board as ESP32 dev. Right. Select DOIT ESP32 dev kit version 1 and keep the framework as Arduino. And here you can select a location to uh, save your project, or you can keep use default location. So I will keep use default location, then select finish. Select yes. Right. Now our project has been created. uh, right, this is our folder structure. Right, inside the source folder we have our main C++ file. uh, this is where we write our code for the microcontroller, and we have another file called platformio.ini. This whenever we install libraries to the uh, project, this will be indicate here. So this indicate details about the project. Go to the Wokwi online editor, and this diagram.json file uh, contains a description about the circuit setup. Right, copy it, and in the root directory of our project, create a new folder as uh, diagram.json. Right, so uh, automatically this file will be opened using Wokwi simulator. So if you are using Wokwi simulator for the first time, this may indicate as unlicensed. So then you need to go to the uh, Wokwi website, and this will redirect you to the Wokwi website, and then you can log into your account. Then uh, the Visual Studio Code environment, you can get community license. Using community license, you can't directly edit diagrams uh, with the Visual Studio Code. So therefore, we need to go back to the online editor and edit the diagram. So open the diagram.json file as from text editor and paste the code. save it and close. Right. Now open the diagram.json file. Right. Now we can see the our circuit setup. Right. To connect with the Wi-Fi, ESP32 board has an inbuilt library called Wi-Fi. Right. So what is a library? Uh, uh, Simply, a library is a piece of code written by someone else. So we can use it within our project. So when we develop software, we do not build it from the scratch. So we use libraries. So using that, so here using Wi-Fi library, we are trying to connect to the Wi-Fi network. So open PlatformIO and go to libraries and search for Wi-Fi. Wi-Fi. You can see Wokwi has a ESP32 board has a built-in library called Wi-Fi. Right. So first include Wi-Fi.h library, and then define the pin which we have connected our LED. Right, we have connected to the ESP2 pin. So hashtag define LED pin has 2. Then I can delete this my function and my function from the starter template, starter code. Right now let's write setup function. So serial dot begin to start the communication. Then we need to define the pin mode. LED pin is a output device. At the start, I need LED to be off, so I say digital write LED pin is low. So then I will create a new function, a function to connect with Wi-Fi. The return type is void, and function name is connect to Wi-Fi. So to connect with Wi-Fi, we need to define our Wi-Fi SSID ID and the Wi-Fi password. Here I am in a Wi-Fi network. My Wi-Fi name is Chamidus Galaxy M Note 2. But here I can't use directly this SSID and the password because I'm using Wokwi simulator. So the simulator can't directly access the Wi-Fi. So it do not have uh, the actual we do not have a physical device actually, so we have a simulator. So Wokwi provide us a simulated Wi-Fi environment called Wokwi guest. So rather than giving our actual Wi-Fi SSID and password, since we are using the Wokwi simulator, we should give Wi-Fi SSID as Wokwi guest and the password as a empty string, right? Okay, then let's say Wi-Fi dot begin and pass our SSID and password. Then the using Wi-Fi library, the it will try to connect to the uh, Wi-Fi network. So now I say until connecting, I want to print as connecting to Wi-Fi. Then we need to wait for until connecting establishing. So we use a while loop while Wi-Fi dot status is not connected. That means until Wi-Fi is connecting, so while Wi-Fi is connecting, I want to uh, let's say our Wi-Fi does not connect, right? So then the Wi-Fi status, so while it connecting, I want to retry. It's like I want this while loop to continue. So with 500 milliseconds, it will retry to connect with Wi-Fi. So let's say at the first try, if if it got failed to connect with the Wi-Fi, then after 500 milliseconds, uh, it will retry again to connect with the Wi-Fi network. So if it successfully connected, the it will come out from the while loop. So once the connection is established, I want to print as connected to Wi-Fi and the the IP address. Let's print serial.print print connected to Wi-Fi. Then after successful connection, I need to turn on the LED to indicate successful connection. So I say digital write LED pin high. So once the ESP32 board connect with Wi-Fi network, it will uh, switch. It will turn on the LED. Here you need to change the SSID and password as SSID as Wokwi guest and the password as a zero as a empty string, right? Right now let's build this program. So if you are using an actual microcontroller, what you do is you build this and plug the code to the microcontroller. So while building, this code will get converted into a byte code and you will upload that byte code to the microcontroller's memory. So then the microcontroller's processor will execute that byte code. So here we are using the simulator, so it also indicate the same. So like if you are building, the code get converted to a byte code and it will get upload to the uh, microcontroller's memory, right? So the project is successfully building. Okay, the project got built successfully. Now let's try to open the diagram.json file. And start. Okay, it's showing me an error indicating that Wokwi.toml configuration file is not found. So open the documentation. Okay. Right. In the documentation, they say we need to have a Wokwi.toml file, a file as Wokwi.toml in our root directory. So where we need to give a firmware and ELF file locations. So let's go to our root directory and create a new file as wokwi.toml. Then copy this code and paste it here. So after successfully building the project, you will get two file paths for firmware.bin file and the for the firmware.elf file. Uh, so replace firmware as for the file path for the firmware.bin file and elf as the file path for firmware.elf file. Then save it and go to the diagram.json file and start the project, start the simulation. Right, right. Now it's compiling and started. Right, but seems like it's not getting connect to the Wi-Fi. Right, I feel like I have made some mistakes. So let's go back to the main C++ file. Right, right. In the main C++ file, I have the Wi-Fi function defined. Right, yes, but in the I have not called the connect to Wi-Fi function. So I only say in the setup I am not telling to connect with Wi-Fi. So I need to call the function. So I am here I'll open the Wi-Fi connection. So say call the connect to Wi-Fi function. Right. So then build again. Okay, successfully built. Now let's go to the diagram.json file again. And start the simulation. Right. Right. Now you can see it's trying to connect to Wi-Fi. Right. Got connected to the Wokwi guest Wi-Fi network. Right. After connected to Wokwi guest uh, network, and you can see after connecting to the Wi-Fi, our LED is blinking. Right. Okay, fantastic. Now with that project completed, let's move to our main project. So it's about building a smart light that we can control remotely using Arduino IoT Cloud. Arduino IoT Cloud is a platform that allows users to connect their IoT based devices to the internet and uh, manage them remotely. So it is a tool for building IoT based applications. Now let's create a project in Arduino IoT Cloud. First, search for Arduino IoT Cloud in your browser. Then go to the Arduino IoT Cloud website. So this is the main landing page of the website. So here you can sign up using your Gmail and select the free plan. So then click get started. This is the home page. So using the free plan, you can create two things. A thing is basically a project. So using free plan, we can create two projects in Arduino IoT Cloud. So click on create a new thing. So then let's rename our project. Let's name it as Smart Light Project. Right. Then add a variable. Let's name it as IoT bulb state. Then select the variable type as Boolean. Give the permission as read and write and select add variable. Here what I want to do is, whenever this variable's state get changed from false to false to true, I need to turn on or turn off the bulb in my circuit. If the variable's value is false, the bulb need to be switched off. If it is true, the bulb needs to get turned on. Then go to the main panel and select dashboards. Select create dashboard. Rename the dashboard. Let's name it as Smart Light Project Dashboard. Then click add. Here you can add different widgets to your dashboard. So I'm selecting a switch. Let's rename it as IoT bulb switch. Right. Then go to edit settings and link this switch to the variable in Smart Light Projects IoT bulb state variable. So whenever I turn on or turn off this switch, the variable's value will get changed, and according to the variable's value, the LED in our circuit will get turned on or turned off. Then from the main panel, go to devices. Then select add device. So here, if you have a physical board, you can select Arduino board. So since we are using a simulator, we need to select third party device. Select the board as ESP32. Select the model as DOIT ESP32 DevKit V1. So then give a name for the device. Let's name it as Smart Light Project ESP32. Then you will get to a device ID and secret key. So you can download them as PDF. So that's it. So we have successfully created the project in Arduino IoT Cloud. So using the secret key and the device ID, we can connect our circuit to the Arduino IoT Cloud. Right. So you can see our device is in offline state. So then you need to go to the associated thing and link this device with the thing we created in Arduino IoT Cloud. Then let's create our project. First create a new folder in your desktop and open it with Visual Studio Code. Then go to PlatformIO and create a new project. Let's name the project as IoT Arduino IoT Cloud Light System. Then select the board as ESP32 Dev. So DOIT ESP32 DevKit V1. Keep the framework as Arduino and I use the default location to save my project and click finish. So as the first step, we need to set up our circuit board. So so in the root directory, create a new file as diagram.json. Then open the diagram.json file in text editor. Then let's go to the Wokwi online editor and design the circuit. So this was our circuit, and this is the diagram.json file. So which contains a description about the circuit setup. So copy this and paste in the diagram.json file. So we can see the circuit setup from our VS Code. So then go back to the Arduino IoT Cloud dashboard. So you can see we have created the device, and it is associated with the project we created. So you can see our device is currently in offline state. So go to sketch. So here they have given us a online editor. So if you have a physical device, you can write your code in this online editor and run it. But in our case, we are using a simulator. So go to this things.properties.h file. So this file contains a description about our project, right? So this was generated by Arduino IoT Cloud. So this is a description about our project, right? So copy this and in our root directory create a new file as things.h. thing thing properties.h. So then rename the device login name and device key as per the keys we get from that PDF, and SSID and password for the Wi-Fi network as Wokwi guest and as an empty string. So you can see here we have included two libraries, Arduino IoT Cloud and Arduino Connection Handler. So go to libraries, then install these two libraries in the project. For search Arduino IoT Cloud. Right. So we need to install Arduino IoT Cloud. Then select the project. Right. Select the project and click Add. So we have installed the two libraries. So then go to the main CPP file. So from the starter code, we can delete these two functions. So to connect with Arduino IoT Cloud, we are using Arduino IoT Cloud library. So go to the Arduino IoT Cloud library documentation. So in the documentation, they have given us how we should use this library to connect with Arduino IoT Cloud. So, so first we need to include the string properties.h file to the main.cpp file, and we need to change our setup function like this, and the loop function like this. So let's go to the uh, main.cpp file first. So in the circuit setup, we have connected the LED to the ESP2 looping. So here I'm saying hashtag define cloud controlled LED pin is 2. Then we'll copy this code from the documentation and saying cloud controlled LED pin is a output device. So here I don't need to use the equal mark, equal sign, right? So in our thing properties.h file, there is a function called init properties. So we need to include the thing properties.h file here. So include thing properties.h. Since I'm in the root source directory, I need to go back one and include thing properties.h file here. Right. So copy this function name and call this function. Right. Then Arduino Arduino Cloud library has a method called begin, and we need to pass a parameter as Arduino IoT preferred connection, which is defined in the thing properties.h file. So in the loop function, we need to call Arduino Cloud.update method. So you can see in thing properties.h file, there is a function as on IoT bulb state change, and there is a variable as IoT bulb state. So which is the cloud variable we created. And in the init properties function, Using Arduino Cloud at property method, we are passing four parameters: IoT bulb state, read write, on change, on IoT bulb state change. Here what happen is, whenever the cloud variable IoT bulb state variables value get changed, on IoT bulb state change function will get called. So we can go to main.cpp file and we can say on IoT bulb state change, if the bulb state is true, I need to make the LED pin high. If the bulb state is false, I need to make the LED pin state low. Here what happen is, in our IoT cloud dashboard, we have a switch which is linked to a variable named as IoT bulb state. So when the switch get turned on, the variable's value is true. If the switch is off, the variable's value is false, right? So whenever the variable's value get changed, the on IoT bulb state change function will get called. So whenever the on IoT bulb state change function get called, I am saying to digital write, make the cloud control LED pins value high. If the IoT bulb state is false, make the cloud control LED pin low. So that's it. So we'll build this. So I'm getting an error saying I need to include Arduino debug utilities.h to the main CPP file. So this was a library which contained in the Arduino IoT Cloud library. So I should include Arduino IoT Cloud library to my main CPP file. So save this and let's build it again. the project got built successfully. So let's go to our diagram.json file and run the simulation. So I need to add the Wokwi.toml file. So let's go to the documentation. Right, copy this, create a new file as wokwi.toml in the root directory and paste here, and get the file path for the firmware.bin file. And get the file path for the firmware.elf file. Right, save it and run the simulation again. Here you can see uh, Arduino Cloud library by default has functionality to connect with Wi-Fi. So first it's trying to connect with Wi-Fi. So first time it got failed to connect to Wokwi guest Wi-Fi network. Then it's retrying again in 4 seconds. Yeah, in the second attempt it got connect to the Wokwi guest Wi-Fi network. Then after connecting, it's trying to connect to the Arduino IoT Cloud platform. Connect to the Arduino IoT Cloud. The thing ID is this, which is our thing ID. And if I go back to my dashboard, now you can see it's showing our device as online. Right? So let's go to our dashboard. Right, let's turn on. Yeah, it's saying that MQTT client connection lost and disconnected from Arduino IoT Cloud. So let's wait and it will get reconnect again. Right, it got reconnected. Then you can see whenever I turn on the switch in the dashboard, the bulb got turned on. Whenever I turn off the switch, the bulb gets turned off. So here we have a IoT system which we can control using Arduino IoT Cloud. So under the hood, the communication between ESP32 and the cloud happens using MQTT protocol. and which is handled using the Arduino Cloud library. For that's it for this tutorial, and congratulations, we have created the uh, IoT application from the scratch. So with this foundation, you can create more advanced IoT projects now. Thank you for joining with us, and if you find this tutorial valuable, consider subscribing and share it with your friends. So have a nice day. Thank you very much.